Good morning, dear students. In the last class, we are discussed about the variation properties and oxidation states also we are discussed. And today I am going to discuss about the physical properties of 13th group elements. Physical and chemical properties of 13th group elements. Okay, physical properties. In the physical properties, boron being extremely hard. Boron is a very hard and it is a solid of high melting point, low density. Being extremely hard, refractory solid of high melting point, low density and very low electrical conductivity. Electrical conductivity is low. So physical properties. Physical properties. What are the physical properties is there? First point, boron extremely hard. Boron being extremely hard. Extremely hard. Okay. Boron being extremely hard solid. It is available in the solid form. Hard solid of high melting point. MP means melting point. Okay, boron being extremely hard solid. It is having the high melting point and low density. Density is low density. And what about the electrical conductivity? And very low electrical conductivity and very low electrical conductivity. Okay, boron being extremely hard solid of high melting point, low density and very low electrical conductivity. And boron exists in two allotropic forms. One is a amorphous boron and another one is a crystalline boron. Okay, boron exists in two allotropic forms, amorphous boron and crystalline boron. Okay, allotropic. For suppose carbon also having the allotropes C13, C14. Like that, boron also having the allotropes. Okay, boron exists in two allotropic forms. Okay, boron exists in two allotropic forms. One is a amorphous boron. Amorphous boron. Second one is a crystalline boron. Okay, one is a amorphous boron, second one is a crystalline boron. Boron exists in two allotropic forms. Okay, and amorphous boron dissolves in molten aluminium at 1530 degrees Celsius. Here molten aluminium means amorphous boron dissolves in molten aluminium at 1530 degrees Celsius, which on cooling gives yellow colored crystalline solid. Aluminium is eliminated by dissolving in HCl, hydrochloric acid. This results in very hard crystalline boron. Here molten state is there. What is a molten state? Molten state means become liquid at the high temperature. That solid become converted into the liquid. That is a become liquid, molten. Next point, boron, amorphous boron. Dissolves in amorphous boron dissolves in molten aluminium. Molten aluminium at 1530 degrees Celsius. Okay, amorphous boron dissolves in molten aluminium at 1530 degrees Celsius, which on cooling gives yellow colored crystalline solid. Okay, at the high temperature 1530 degrees Celsius, amorphous boron dissolves in molten aluminium. Molten means become liquid. Okay, at 1530 degrees Celsius, which on cooling, what happen? It will be gives yellow color crystalline boron. On cooling, it will gives yellow colored crystalline solid. Yellow colored crystalline solid. Yellow color crystalline solid. Okay, amorphous boron dissolves in molten aluminium at 1530 degrees Celsius, which on cooling gives yellow colored crystalline solid. Okay, aluminium is eliminated. Then aluminium, how it will be eliminated? By dissolving in hydrochloric acid. First, amorphous boron dissolves in molten aluminium, okay, at 1530 degrees Celsius. After that cooling, it will be gives the yellow colored crystalline solid. And in that aluminium also there. Then aluminium, how can eliminated? Aluminium is eliminated by dissolving hydrochloric acid, HCl. This results in very hard crystalline boron. Then we can get the only boron. Okay. Now, colored crystalline solid. Aluminium is eliminated by dissolving in HCl. HCl means hydrochloric acid. Dissolving in HCl, this results in very hard crystalline boron. This results in very hard crystalline boron. Okay, after that we can get the very hard crystalline boron. Okay, this is a boron we can abstract. Amorphous boron dissolves in molten aluminium at 1530 degrees. On cooling gives it is yellow colored crystalline solid. Aluminium is eliminated by dissolving in HCl. Then we can get the crystalline boron, hard crystalline boron. And next, boron is non-conductor of electricity. Already the first we discussed. It is a low electrical conductivity. Okay, boron is a non-conductor of electricity. Okay, boron is a non-conductor of electricity. Next, boron sublimes at ordinary pressure. Boron sublimes at ordinary pressure. Boron sublimes at ordinary pressure. Okay, these are the physical properties of 13th group elements. Okay, boron being extremely hard, it is a high melting point, low density, low electrical conductivity. Boron exists in two allotropic forms, amorphous boron and crystalline boron. And amorphous boron dissolves in the molten aluminium at high temperature, that is 1530 degrees Celsius, which on cooling gives yellow colored crystalline solid. Aluminium is eliminated by dissolving in HCl. This results in very hard crystalline boron. Boron is a non-conductor of electricity. Boron sublimes at ordinary pressure. Now I'm going to discuss about the chemical properties of 13th group elements. Okay, first chemical property is action with air or oxygen. Action with air or oxygen. Okay, now chemical properties. Chemical properties. Okay, what are the chemical properties is there? Okay, first property, action with air. First one is action with air. Air means in the air oxygen is there. Air or O2, oxygen. Okay, so action with air or oxygen. Amorphous boron on heating in air to about 700 degrees Celsius form B2O3 and Bn. B2O3 is a boron oxide and Bn is a boron nitrate. Okay, amorphous boron. Amorphous boron means without a clearly defined shape or form is a amorphous. Amorphous means what? Without clear shape or form, without clear shape or form, called amorphous. Okay, amorphous boron exists in two forms. One is a crystalline boron. Crystalline means pure solid, exactly structure will be there. And what is the amorphous? Without a clearly defined shape or form, there is no clear shape, that is amorphous form. Okay, so amorphous form, amorphous boron on heating in air, what happened? Amorphous boron on heating air at the 700 degrees Celsius to form B2O3 and boron nitrate. Amorphous boron on heating, which temperature? On heating in air, at 700 degrees Celsius to form B2O3 and Bn, boron nitride. Amorphous boron on heating in air at 700 degrees Celsius form B2O3 and boron nitride. Okay, now I will write the reaction. 4 moles of boron is reacting with air. Air means oxygen. 3 moles of oxygen. 4 moles of boron, 3 moles of oxygen react with to form B2O3. Here B2O3, boron oxide. When boron is reacted with oxygen to form boron oxides. And the next one, boron nitride. When it will be formed? Air means oxygen and nitrogen also there in the air. So when it is reacted with nitrogen, it will be formed boron nitride. 2 moles of boron is reacted with nitrogen to form 2 moles of boron nitride. Boron nitride is a inorganic graphite. Boron nitride we can call the inorganic graphite. It is important. Okay, which one we can call the inorganic graphite? Boron nitride, Bn, boron nitride we can call the inorganic graphite. Next one, this is the reaction with air. Next, reaction with non-metals. Next point, reaction with non-metals. Reaction means reaction with non-metals. Okay, reaction with non-metals. On heating, amorphous boron will react with nitrogen, oxygen, sulfur, fluorine, chlorine and bromine, directly forming binary compounds. Nitrogen, oxygen, sulfur, fluorine, chlorine, these are the non-metals. On heating amorphous boron, when we are heating amorphous boron, On heating, amorphous boron will react with nitrogen, oxygen, sulfur, fluorine, chlorine and bromine directly forming binary compounds. Okay, now write the reaction. 4 moles of boron is reacted with 3 moles of oxygen. Already I given this reaction to form 2 moles of B2O3. Oxygen is a non-metal. Okay, boron is reacting with non-metals. And sulfur, we have to take the sulfur. 2 moles of boron is reacted with 3 moles of sulfur to form B2S3. Boron trisulfide. What is the temperature? In presence of 1200 degree Celsius. It will be formed boron trisulfide. What is the name? B2S3, boron trisulfide. Okay. Hardest compound of boron is boron carbide. This is important. Hardest compound of boron is boron carbide. Hardest compound of boron is boron carbide. Okay, hardest compound of boron is boron carbide. Formula is B4C. Boron carbide formula B4C. So hardest compound of boron is boron carbide. Formula is B4C. So this is an important point. Boron carbide is okay. This is about the physical properties and chemical properties with action with the air and with non-metals. Next, reducing property. Okay, so reducing property we can discuss in the next class. Okay, thank you all of you. Bye. Have a nice day.